All right, welcome. Let's learn about dividing polynomials. And today, we're going to specifically learn how to do that using what's called the reverse tabular method. So if we're going to use reverse tabular method, I think that probably we should make sure that we remember how to get that out of the way, first of all. But that we remember how to use our tabular method, right? So here we go. Let's go ahead and multiply these two polynomials using the tabular method. Here we go. So I notice that I have a trinomial and I have a binomial. So I am probably going to need a 3x3 table right away. And there it is, 3x3. All right, on the top, I'm going to put this trinomial x squared plus 5x plus 1. And over here, for my rows, I am going to put the 2x plus 5. But I have to keep in mind that these have to go x squared, x, and a number, right? I've got it. In other words, they have to be in descending order according to my degree of the polynomial. So we start with x squared, x, and then our constant term, and then we'll put a 0x squared, because that's what's missing from 2x plus 5. And my x term, and then here's my constant term. Let's go ahead and multiply. 0x squared times x squared is 0, right? X squared times 2x is 2x cubed. X squared times 5 is going to give me 5x squared. 5x times 0 is 0. 5x times 2x is 10x squared. 5x times 5 is 25x. 1 times 0 is 0. 1 times 2x is 2x. And 1 times 5 is 5. Remember, we're going to add diagonally the 0 that's in the top left-hand corner. Doesn't have anything to add, so it comes out. It's just 0. But it doesn't make a difference for the problem, right? So just want to show you that spitting out 0. I'm not going to put anything there because we're not going to actually include it in our final answer. So let's look at the next diagonal. That 2x cubed plus 0 is, of course, 2x cubed. And our next set of diagonals, 5x squared plus 10x squared plus 0 is going to be 15x squared. The next set of diagonals we'll look at, 25x plus 2x is 27x, and that 5 has nothing to add. So we can say that this polynomial expression, right, this product, is equal to 2x cubed plus 15x squared plus 27x plus 5. There we go. Interesting. How would I use the expression in a part A to quickly multiply 25 times 151? And what Eureka is really trying to get us to look at is the structure of division. How are division and multiplication related? And obviously they're opposites, right? So let's look at that. It turns out that 25 times 151 is equal to 3,775. Okay. Well, I could rewrite that in two different ways. I could rewrite that in terms of division. I could actually manipulate this equation, right? If I divide both sides of this equation by 25, I have 151 is equal to 3,775 divided by 25, right? If I divide both sides by 25, On the left-hand side, those 25s cancel. And on the right-hand side, I have that expression, 3,775 divided by 25. In the same way, if I was to divide both sides by 151, I also have this equivalent equation, which is 25 is equal to 3,775 divided by 151. Okay. And this is really nice for a good explanation for how we're going to get to reverse tabular method for division. But if we're going to answer this question here, what we've got is actually, it looks like if we were to go ahead and substitute 10 in for x. So let's go ahead and that's the answer to this question. I'm going to put it up here. So we're going to let x equal 10, right? And I'm going to move that into a different spot so it doesn't get confused with what we're doing. If x is 10, then it looks like I have 2 times 10 cubed plus 15 times 10 squared, all right? Plus 27 times 10 plus 5. Turns out that that is 2,000 plus 1,500 plus 270 plus 5. And while it's not essential for us to do that, it's kind of neat to see that we have this polynomial representing the different place values that we have in our base 10 number system. Right? This 2x cubed is actually representing our thousandths place, right? Cubed, right? Because 10 times 10 times 10 is 1,000. And then our x squared is representing our hundreds place. The x, the tens place, and the 5 is the ones place. And obviously, since that 270 is greater than 100, it winds up carrying over. So, just an interesting result that we'll look at maybe a little bit later. Okay. As long as I don't screw up this board here, we're good. Like that. Here we go. So, the next thing that we're going to need to do is undo moving that. All right, here we go. So let's look at that. Hey, does 2x cubed plus 15x squared plus 27x plus 5 divided by the quantity 2x plus 5 equal x squared plus 5x plus 1? Okay, well, let's see. How are we going to find that out? Well, it looks like we're prompted to use the tabular method to multiply this. So let's do it. Okay, so if we're using our tabular method, isn't this the same thing as saying, right? If I was to, let's go ahead and just write the whole thing out. And what I want to do is multiply both sides by 2x plus 5 to get a feeling of the way that this thing is going to work. All right, so if I multiply both sides by 2x plus 5. On the left-hand side, the 2x plus 5 will cancel. Right? So then I wind up with 2x cubed plus 15x squared plus 27x plus 5 is going to be equal to, hopefully I don't run out of room, 2x plus 5 times x squared plus 5x plus 1. Ooh, I barely squeezed it in there. I'm going to go ahead and rewrite that for neatness. Okay, 2x cubed plus 15x squared plus 27x plus 5 is equal to 2x plus 5 times x squared plus 5x plus 1. There we go. Right, and all I did was multiply both sides by 2x plus 5, the entire quantity. So I've actually written this problem in a different way. I took a division problem and I wrote it as a multiplication problem, which is kind of what we're doing. We're going to use an approach that we have to multiplication in order to work backwards and divide. So when we are multiplying, we're using this tabular method to multiply. Our answers pop out right here, don't they? Sorry, I started to put the wrong values there. So if we're writing it this way, our answer is 2x cubed. 15x squared. We have a 27x here. And we have a 5. Alright, so that says that our answer to this, right? Or the product of 2x plus 5 times the quantity x squared plus 5x plus 1 is equal to, right there on the outside, 2x cubed plus 15x squared plus 27x plus 5. All right. So let's look. We know that inside here, that's got to be 2x cubed. That is a really easy one to figure out how to fill in. All right, but now we need to think about what we're actually trying to arrive at, right? If we look at the very beginning where it says 1 does, right, the problem that Eureka is asking us for, what would we fill in? We want to show if x squared plus 5x plus 1 is actually the quotient that they're asking for. So let's go ahead and put our 2x here and our 5. And let's go through this process. Those are very close together, and that looks funny. So let's fix that. We got a 5 here. I'm just going to put this 5 closer. Okay, so I'm going to fill in that top row. It turns out that that top row is going to be the answer to 2x cubed plus 15x squared plus 27x plus 5 divided by 2x plus 5. And just bear with me, it's going to make a lot more sense as we do a whole bunch more problems. This is our first time, so just watch, and then we'll see the pattern for it. All right, so I need to ask myself, hey, how did I get that 2x cubed, right? What did I need to multiply 2x, right? The quantity there on the right. What did I need to multiply that by to get 2x cubed? Well, it's got to be x, right? Because, or x squared, because 2x times x squared is 2x cubed. All right. Excellent. So now it's easy for me to get this lower one, right? Because x squared times 5 is 5x squared. Now I need to fill in the box diagonally up and to the right of 5x squared. So I have to think to myself, how did I get that 15x squared if I was doing the regular tabular method for multiplication? Well, I had to add, right? So something plus 15x squared, something plus 5x squared is 15x squared. What number would that be? 10x squared. Or what quantity would that be? 10x squared. All right, now I need to fill in the top. And in order to do that, I need to say, hey, what did I have to multiply 2x by to get 10x squared? And that turns out to be 5x, right? Because 5x times 2x is 10x squared. And then I can just multiply the 5x times times 5. And that's going to give me 25x. And now again, this 27x, how did I get that? If I was using tabular method for multiplication, I would be adding 25 plus some quantity to get 27x. That quantity's got to be 2x, right? Okay, now time to fill in our uppermost quantity. And in order to do that, I need to think, hey, what did I need to multiply 2x by? To get 2x, the only thing that does that is 1, right? Because 1 times anything is just going to be itself. And then it's really easy to get this last one, and it's not even actually necessary in this case because there is no remainder, but 1 times 5 is 5. Hey, it's really important that we check that the last number matches, the last number in the box matches the last number on the bottom. Because if that's so, then there's no remainder. And we'll talk about remainders in a whole lot more detail later on. For now, everything that we'll do will not involve remainders. If you would like to go through and describe the process for number 2, be my guest. I just described it, so I'm not going to do it again. I'm just going to do some more example problems. So if you want to go through and talk it out to yourself in writing, I think that's beneficial. If you would just benefit from seeing more examples, let's do this. All right. So let's do another example. So we're going to find this quotient. I'm always going to start by writing my numerator along the outside. And then my denominator, or my divisor, is going to go over there on the right-hand side. So 2x squared has got to go in there. That's an easy one to fill in. It's always going to match. Now to get the top, I need to think, what do I multiply 2x squared by to get x? Well, that's going to be just 2x, right? Okay, and then 2x times -2 is -4. Now I need to figure out what's in that upper right-hand box. Well, I added something to -4x to get x. What would I add to -4x to get x? 5x. All right, and what do I multiply x by to get 5? That's what's going to go above that 5x, and that is 5. And then 5 times -2 is -10. Awesome when those two match, right? Because that means that I don't have a remainder. So then I can say that this quotient is equal to, right, this quotient 2x squared plus x minus 10 divided by the quantity x minus 2 is equal to 2x plus 5. Don't worry, we'll do more examples. All right, so let's do another one. Now, the difference between this one and the previous ones is that we haven't been given our table ahead of time, which means that we need to do a little extra work to figure out the dimensions of our table. In other words, how many rows and how many columns should our table have? Well, it turns out that our rows is going to be equal to the degree of our divisor plus 1. All right? So what's the degree of our divisor? 2. In other words, the degree of our denominator, it's another way to say that in this case. And then our columns will be 1 more than the difference between the degree of our dividend in our divisor, or the degree of our numerator and denominator. So in this particular case, it's going to be 4, since the degree of our numerator is 4, minus 2 plus 1. All right, and I'm going to actually write that out for you guys. So rows is going to be degree of, I'm going to write numerator instead of, I'm sorry, denominator instead of divisor. So degree of denominator that's one quantity plus 1. Okay? And our columns is going to be our degree of our numerator minus the degree of our denominator plus 1. So that's how we're going to figure out the dimensions of our table. So I've used a bunch of space, but let's see if we can fit this in there, which means that we should have 3 rows and 3 columns. So it's really important for us to determine that before we get started, or things could get very messy. And I need a little more space. So I'm going to go ahead and extend the page. And do it over here. Oh, I need the actual problem. So I'm going to do it over here. Here we go. So a 3 by 3 table. And I'm going to put my numerator on the outside. So I'll have x to the 4th, 4x cubed, 3x squared. And then over here I need the 4x and the 2. And when it works out like that, I know that I chose the right number of columns and rows. Okay, so our numerator, right, the expression that we have on the top, is going to go on the outside. Our denominator, the expression on the bottom of our quotient, is going to go on the right-hand side, but it looks like I'm missing that x term, right? So that means that I have to put a 0x in here. Remember, guys, we need those placeholders, and that's why it was so important for us to put those placeholders in when we were learning the tabular method for multiplication. Because when we come to this, it's very important. All right, so now we can actually go through the process of doing this division. So always, those two are going to match. It just comes right out the outside. All right, what did I have to multiply x to the fourth by to get x squared? That is x squared. And now I can just multiply x squared times the quantities on the right-hand side outside of my table in order to fill in the other two boxes in this column. So that's 0 and x squared. Now I got to think to myself, hey, how did I get that 4x cubed? In other words, what did I need to add to 4x cubed? Sorry, what did I need to add to 0 to get 4x cubed? Well, that one's easy, right? 4x cubed, right? And the reason for that is, remember, we're adding diagonally. Okay, now I'm going to go ahead and figure out what goes on the top. So in other words, what did I have to multiply what did I have to multiply x squared by to get 4x cubed? That is going to be 4x, right? Because 4x times x squared is 4x cubed. Now I can multiply to get the remaining column. 4x times 1 is 4x. And now I want to know what's going to go in that very top right-hand box or cell, if you will. And in order to do that, I say, hey, I've got an x squared and a 0 in there. I had to add something to those to get 3x squared. What would that be but 2x squared? So 2x squared plus x squared is 3x squared, so that works. In order to fill in the top, I need to figure out what I would multiply x squared by to get 2x squared. Well, it's got to be 2. And then I can finish filling it in if I want to. The answer's on the top. The reason why I'm going to finish filling this in is just to make sure that there's no remainder. And there isn't, because I've got a 2 in my box and a 2 below the box there, and as that last entry. And when those match, no remainder, and that's awesome. And we're not going to be dealing with the remainders for a while, but I just want to make sure to tell you why we're doing that. All right? So then the answer is x squared plus 4x plus 2, right? Our answer is always going to be the number that we have, or sorry, the quantity, the polynomial that we have on the top. All right, let's do another one. Well, here's our problem. So the first thing that we need to do is figure out how many rows and columns will be in my table. All right, so my rows. Let's remember how we do that. It's going to be our degree of our denominator plus 1. So our degree of our denominator is 2 plus 1, so there will be 3 rows. How many columns will there be? Well, that's going to be the degree of our numerator minus the degree of our denominator plus 1. So 3 plus 1, or 4. So 3 rows, 4 columns. There we go, 3 rows and 4 columns. Remember, our numerator is going to be what we put on the outside here. So negative 2x to the 4th, right? Because that minus sign does live with that 2x. It is a negative 2x to the 4th. There's our 6x to the 3rd. And then remember, it's like I'm going to skip one because we're thinking about diagonals, right? So that's why I'm going to put the, not that. So I'm going to put the negative 4x squared here, negative 24x, and 16. And it's awesome when they line up like that because that means that I chose the correct number of rows and columns. So I'm going to go through this process. Remember, the first thing I'm always going to do is fill that in. And also, I have forgotten to put my x squared. And remember, I got to put a placeholder for the x. And my 4 there. Okay, what did I need to multiply x squared by to get 3x to the 5th? That looks like 3x to the 3rd power, right? Because I have to add my exponents, right? So the first thing I'm thinking is, hey, how do I get from 2 to 5 if I'm adding? Well, that means the exponent has to be 3. I'm going to multiply to get the rest of the column. 12, oops. How about 12 instead? All right, 3x cubed times 4 is 12x cubed. Okay, now we're back in business. All right, so now I'm going to go and look at this negative 2x to the 4th. I had to add something to 0 to get negative 2x to the 4th. The only thing that works there is negative 2x to the 4th. Then I got to figure out what goes on the top. What did I multiply x squared by to get negative 2x to the 4th? How about negative 2x squared? And now I'll multiply straight down to get the remaining values in that column. Next, I'm going to look at that 6x cubed. How did I get 6x cubed? I had to add something to 12x cubed. Well, if I added negative 6x cubed, that would work, right? 12x cubed minus 6x cubed is 6x cubed. Fantastic. Now I get to figure out what my top value is there. What did I multiply x squared by to get negative 6x cubed? Well, how about negative 6x? All right, negative 6x times 0 is 0, right? Again, I'm just multiplying to figure out what goes in the remaining cells in this column. All right, now I'm going to look at my 4x squared, and that is an 8. That negative 4x squared. What did I have to add to 0 and 4x and negative 8x squared to get negative 4x squared? Turns out that that is 4x squared, right? Because negative 8x squared plus 4x squared is negative 4x squared. Fantastic. What did I multiply times x squared to get 4x squared so that I can fill in this top value? It's going to be 4. All right, now I have my answer, but I'm just multiplying the thing out just to make sure that there's not a remainder and there's not, since that 16 matches with the other 16. All right, let's continue and find a couple more quotients. Okay, so first of all, if we're going to do the x to the 5th minus 1 divided by x minus 1, we've got to figure out the dimensions of our table. So our rows will be all right, let's fix this pen real quick. Have a little smartboard issue here. All right, so let's figure out how many rows. Once again, it's going to be 1 plus 1 because the dimensions of our denominator, the degree of our denominator is 1, and we're going to add 1. In our columns, is going to be 5, right? The degree of our numerator, minus 1, the degree of our denominator, plus 1, so that's going to be 5. So let's go ahead and put a 5 by 2 table. All right, so we have a 5 by 2 table. Here we go. So we're going to have a lot of placeholders with this one. All right, so let's go ahead and put our x to the 5th here. And then we're going to have a 0x to the 4th, 0x to the 3rd, 0x squared, 0x, and negative 1. And then over here we'll have x and negative 1. All right, let's go through the process. X to the 5th goes here. What did I need to multiply x by to get x to the 5th? X to the 4th. And this one then will be negative 1 times x to the 4th, or x to the 4th. What did I have to multiply 0x to the 4th by to get negative x to the 4th? Or what did I have to add? I think I said multiply, I mean add. Well, that's got to be x to the 4th. What did I have to multiply x by to get x to the 4th? This will be x to the 3rd. We'll multiply down and get negative x to the 3rd here. What did I have to add to x to the 3rd? What did I have to add to negative x to the 3rd to get 0x to the 3rd? Again, it's going to be positive x to the 3rd. X squared. We're going to be able to fill this in pretty quickly because we see a definite pattern forming here, right? And for pre-AP, we're going to get into this pattern pretty hardcore. Perfect. Those two match up, so I know there's not a remainder. So then I know the quotient x to the 5th minus 1 over divided by x minus 1 is equal to x to the 4th plus x to the 3rd plus x squared plus x plus 1. All right, if that's true, then you could make a conjecture about x to the 6th divided by x minus 1. And you would be right if you thought that this pattern continues. And as I said, in our pre-AP course, we are going to really examine why that pattern continues and how polynomials work when we expand them in that way. All right, if you weren't here, go ahead and check the calendar on my webpage for the classwork. Thanks so much for watching. I'm going to see you tomorrow.